Okay, solutions for starter 1. So 4 root x plus 6 over 4x squared. Well, to do this, remember, we split it up. So 4, I can write root x as x to the half over 4x squared plus 6 over 4x squared. 4 over 4 cancels out. X to the half divided by x squared, take away, so it's x to the minus 3 over 2 plus 6 over 4 is 3 over 2, x to the minus 2. Okay, second one, we have y equals e to the 5x cos 2x at pi over 2. And we're going to solve it. We're going to find the exact gradient in terms of pi when x equals 2 pi. So that means differentiate it because it's gradient. We're looking for the product of two things. So I need a u and I need a v. And you differentiate them. So 5e 5x. Differentiate that. Well, cos goes to minus sine. And I have to times by the derivative of the bracket, which gives me 2 different. And then times them. And the formula is uv dash plus vu dash. So I get dy by dx equals minus 2e 5x sine 2x at pi over 2 plus 5e 5x cos 2x plus pi over 2. Yeah, we normally write the e's in front before trig. That's why I wrote that one at the front. Doesn't matter. We sub in x equals 2 pi. So we get dy by dx. Look, I'm not using the calculator yet. Minus 2 e 10 pi, sorry, sine 4 pi plus pi over 2. So that gives me 9 pi over 2 plus 5e 10 pi, 9 pi over 2. Then all I'm going to use my calculator for, look, and I'm using a really old-fashioned one. All we have to use it for, make sure we're in radians, and just do sine of 9 pi 9 pi over 2, and that gives us 1. So I get minus 2e 10 pi times 1, so it's just that. And then do the same thing but with cos. It gives us 0, so that term just turns to 0. So that's just my answer. Yeah, only had to use a calculator for that last bit. Okay, third one. Find the x to the 6 coefficient in the expansion 3x cubed plus 2 to the power 6. Well, to get an x6, I need 2x cubes. So that means I'm going to have 4 number 2s. And so that means my c at the front is going to be 6c, and I could either use 2 or 4. So then I just type my calculator, 6c2, which is 15, times 3 squared. It is 9, so 9x6 times 2 to the 4 is 16, so do 15 times 9 times 16 gives me 2,160 to the 6. So my coefficient is 2,160. Number 4, solve x to the 2/3 plus 3x to the 3rd equals 4. You should get suspicious because there's 3 terms, and this looks like double this power. So if I say y equals x to the 3rd, then y squared, I just times the power by 2, so it's x to the 2/3. So I get y squared plus 3y equals 4. I switch to quadratic clock. Y squared plus 3y minus 4 is 0. Solve that in the calculator. You get y is minus 4. y is 1. Sub back in what y was. So x to the third is minus 4, and x to the third is 1. And to get rid of the powers, remember, the inverse is you do the reciprocal on the other side. So I'll cube this side. So x is minus 4 cubed, which is minus 64, or x equals 1 cubed, which is 1. So the two answers are minus 64 and 1. And the last one. A ball of mass 3 kilograms is dropped vertically from a height 40 meters above the ground. How long does it take to reach the ground? Well, if I take down as being positive, then we're going to use suba because it's going to be constant acceleration. So the acceleration is going to be gravity. The times what we're trying to find. The initial velocity, since it's dropped, it's 0, and the distance is 40 going down. So I don't want v, so it's s equals ut plus half t squared. So 40 is 0 times t plus a half times 9.8 t squared. So 40 is 4.9 t squared. So t squared is 40 over 4.9. Square root it and take the positive answer because you can't have negative time. And we should get 2.857, etc. But since we've used 9.8, we need two significant figures, so 2.9 seconds. Now, that thing about this being 3 kilograms doesn't make a difference. It doesn't matter how heavy something is when you drop it, if we model it as a particle.